Now let's look at a good example of inheritance. Let's imagine we want to model the concept of a stream of data. We can read a stream of data from a file, from a network, or from the memory. All these streams have a few things in common. We can open them, we can close them, we can read data from them. But how we read data from a stream is dependent upon the type of the stream. Because reading data from a file is different from reading it from a network. So let's start by defining a base class called stream. In this class, I'm going to define methods like open and close. So define open. Now here, let's say we need a flag to know if the stream is open or not. So we can define a constructor. And in this constructor, we can set the opened flag initially to false. When we call the open method, we can set this to true, like this. Now, what if we try to open a stream that is already open? That is an invalid operation. So perhaps we want to raise an exception. So we can check if self.opened, we want to raise an exception. What kind of exception? Well, we don't want to do a value error because here we're not dealing with a value. In this example, we can create a custom exception called invalid operation error. We don't have this in Python. In this case, we can create a custom exception called invalid operation error because we don't have a built-in exception in Python that represents this concept. So on the top, let's create another class, invalid operation error. So by convention, all custom exceptions should end with error. Now we want to derive this from the base exception class in Python. So every time you want to create a custom exception, you should derive your class from the exception class. Now here we don't need any code, so we simply add a pass statement. Back to our open method. If the stream is already open, we want to raise an invalid operation error. And here we can give a friendly message like stream is already open. So this is our open method. Now let's define the close method. That's going to be very similar. So to save time, I'm going to copy these few lines and rename this method to close. Now here we want to check if the stream is already closed, we want to raise an invalid operation error. So if not self.opened, we should raise this exception and change the error message to stream is already closed. And finally, here we set open to false. So these are the common features that we need in every stream. Now let's go ahead and implement a file stream. Oops, actually I have a typo here. Sorry about that. So we define another class, file stream, which inherits from our stream class. Now, as I told you before, how we read data from a file is different from how we read it from a network. So I'm going to define a method called read. And for simplicity, let's just print reading data from a file. Save the changes. Now, let's duplicate these few lines and create a network stream class. Network stream. And we should also change the message to reading data from a network. This is a good example of inheritance because first of all, we don't have multi-level inheritance. We only have 1 or 2 levels depending on how you want to calculate it. So we have the stream class on top of our hierarchy, and below that we have 2 subclasses, file and network stream. Now it's okay if we add another level of inheritance here, but we shouldn't go beyond that. Also, as you can see, we don't have multiple inheritance, so our subclasses don't have multiple parents.